Hello everyone, welcome to our session. Is your solar knife sharp enough for the production? In which we are going to talk about the things that we need to consider for solar and Sitecore for production environment. Before that, let's introduce ourselves. My name is Mahendra Sekhawat. I'm a lead developer in RightPoint and I'm a Sitecore Technology MBA 2020 and an active Sitecore Stack Exchange contributor. I have my co-presenter with me, Suya.
Hi, my name is Surya Narayan. I'm working as a senior solution architect at RightPoint India. Overall, I have more than 14 years of experience and 8 plus years of experience I have in Sitecore. Okay, so we are going to cover overview, key consideration while building system with Solar and Sitecore, infrastructure setup, and best practices.
A search functionality is very important in a website development. It is more important when we are developing an enterprise level website which can have thousands of pages with information. And this statement fits with almost every website which is developed in Sitecore. So Sitecore's default search is now based on Solr, so it's more important when we go on the production. For every development team, prod release is a kind of hunting in jungle. So we always prefer that when we go to the jungle, we should have a sharp knife always. And that's why we have chosen this topic. The overview of this topic is to understand the things which are important when we go on the production with the Sitecore and Solr. We'll cover the key consideration while building the system with Solr and Sitecore. Since this is an important as we go live, how to set up the infrastructure, best practice for the Solr setup on the production, things which we need to consider, and the key element to address while launching the website using Sitecore and Solr.
Okay, so before we proceed to set up Sitecore with Solar for production, we need to consider a few points when we are building our system. Because it is always important to develop a good system, and most of performance things are dependent on way we are building the system. So in the key consideration, we are going to talk about the Solar Cloud versus master slave configuration, and then best practices during development, and things like multilingual, stop words, synonyms, and schema management. So here is the Solar Cloud versus master slave comparison. Solar master slave, it's simple to set up as compared to Solar Cloud. Automatic failover for search only and not for indexing. This is a legacy approach and to be replaced with Solar Cloud, and it is also not recommended. On the other hand, Solar Cloud setup is more complex and it requires additional servers for Zookeepers. It handles automatic failover for both index search and updates. This is the recommended system which is supported from Sitecore 8.2 onwards. And here is the typical Solar Cloud high-level architecture where we can see that it has got multiple nodes and then those can be scaled vertically. And in this system, each node is responsible for searching and updating indexes.
Okay, let's talk about the development best practices with Sitecore and Solr. Index only field which are required so that we can limit the index size. A small index is equal to good performance. Index only content tree which is required. Use multiple location crawling. We don't want each and every content in content tree to index. With multiple crawler, we can again limit the index size and scope. Try to use computer index field and avoid the logic after getting the result. Paging is always a best practice for the search-driven control for both UI and the performance. Some developers use get item after getting the result from the Solr, which is not a good practice. And we should only get the required field from the search. Always use select statement to trim the result. For example, search-driven control which only need title and URL, then why we need to get the full object? We can just get the title and URL from the select statement. For filtering result, we should use query filter instead of query because filter query is cached for main query. It increases the performance. Make sure you review schema for custom field and update index and store property as per need. Index true means the field will be used for filtering result or for sorting result. And store true means we can retrieve this field from the result and use it anywhere for any logic. We need to use inbound and outbound index filters for better performance. Instead of using default Sitecore indexes, create custom indexes for functionalities such as blogs, news, etc. Sitecore is a robust solution and it supports the multilingual content in form of versions on language level. But multilingual search is hard as the algorithm within natural language processing pipeline aren't always straightforward. In general, we always have field level language in Sitecore as it is based on the versions. But we can manage it on the code level where we can have multiple codes based on the language. It basically best suit when we have lots of language in our website. Let's take an example of website with 30 languages. If we'll do, if we'll go with the field level language, then it will be 30 times big index compared to a single default language. Using stop word are always good with the searching as we don't want to search each word in the content. Always try to trim your search to a meaningful result. Stop words are something we don't care during the development, but this play a very important role on the production. Like the stop words, synonyms also play a very important role on the production. Let's take an example of keyword television. What we what if we only have TV keyword in the content for our website? For returning the meaningful result, it's always good to have synonyms. Schema management. Sitecore has a very good schema tool. Sometimes we need to analyze fields for the stop word and synonyms and make appropriate changes in the schema. And this is very important when we have multiple language.
Okay, so far what we have discussed is basically for development best practices. Now we will discuss the setup infrastructure for the production. We will discuss the four major things before we take decision for the setting up the infrastructure. Zookeeper ensemble, high availability, load balancer, and scaling. Zookeeper is a top-level software that acts as a centralized service and is used to maintain naming and configuration data to provide flexible and robust synchronization within distributed systems. You can build your infrastructure with a single node, but you won't receive the highly reliable and available system as in a cluster with three or more nodes. An ensemble with three nodes will support one failure without loss of service, which is probably fine for most users, and also this is the most popular setup. A 5-node cluster allows you to take one server out for maintenance and still be able to take a second unexpected failure without interrupting your service. There can be even more nodes if the system is too complex or big. We should also install Zookeepers on a separate servers and make sure to update configuration accordingly. You should have one Zookeeper per Solr node, and if you have two Solr nodes, then you should have three Zookeeper nodes. For setting up infrastructure, let's talk about high availability. You do not want production system to go down either, which is why it is important that your Solr setup supports high availability. It can be done by deploying Solr across multiple nodes, putting a replica of each collection on at least two nodes. This will ensure that even if one of the nodes go down, you will still have access to all of your data. A load balancer distributes incoming queries across Solr nodes. Putting a load balancer on top of your Solr cluster help you achieve a truly distributed and highly available architecture. It adds a layer of security on top of your Solr cluster, and it is a universally supported way of accessing your Solr cluster in a distributed fashion. The goal of auto scaling is to make SolrCloud cluster management easier for providing a way for changing to the cluster to be more automatic and more intelligent. Autoscaling includes an API to manage cluster-wide and collection-specific policies and preferences and root syntax to define the guidelines for your cluster.
Now let's talk about the best practice for Solr production setup. In this, we are going to cover backup, monitoring, vulnerability, performance, permission and security, sharding, and testing. Let's talk about the backup. Why backup is important for the production setup? Because indexes can be corrupted accidentally or mysteriously. Admin activities such as deleting entire collection or updating set of the document to manage cluster without requiring full reindexing also mitigate risk of fail upgrade. Backup are supported through collection API, and this allow the backup in generated across multiple shards and restored to the same number of shards and replicas as original collection. Collection API provides command to backup and restore.
Okay, monitoring. So it is also important to have good monitoring for overall system, and the key things to monitor are like cluster state. If nodes are healthy, and monitor status of shard and replicas. Index related metrics. Monitor throughput, document distribution, IO metrics. For garbage collection, we can monitor count and timing. For search related metrics, you can monitor count latency, distribution among nodes, and anomalies and spikes. For monitoring memories, you should all include heap details, pool size, and utilization. Also, monitoring OS is important, in which you can consider CPU utilization, load, IO operations, and network. And monitoring can be done using web-based admin console, command lines, or using REST APIs. Solr logging configuration. This is also one of the key things to set up. You can update default logging configurations such as log levels, permanent or like temporary logging, etc. Let's talk about metrics reporting. Solr includes a developer API and instrumentation for the collection of detailed performance-oriented metrics throughout the lifecycle of Solr service and its various components.
Java Management Extension. JMX is a technology that makes it possible for complex systems to be controlled by tools without the systems and tools having any previous knowledge of each other. In essence, it is a standard interface by which complex system can be viewed and manipulated. We don't recommend enabling remote JMX access in production, but it can sometimes be useful when doing a performance testing and UAT prior to going live. Vulnerability patching. When you deploy Solr in production, make sure that you only update the settings that you absolutely must change. It is a good practice to do a regular vulnerability scan on your servers to see if there are any specific vulnerabilities that need to be addressed. In addition, it is best to keep yourself updated with the latest discovered vulnerabilities and monitor the Apache Solr mailing list. Once you have discovered a vulnerability for the version of Solr you are using, it is best to apply the patch in a timely manner.
Okay, for the performance, we can improve system performance by checking the high request rate. We just need to make sure server has got enough RAM, OS disk cache is set properly, Java heap is configured well. SSD is also important for IO operations. Also for performance, make sure slow startup, extreme scaling, and slow indexing is handled well. Now talk about the permission and security. Security being an important factor in Solr with Sitecore infrastructure. By default, installation for Solr is open for anonymous visit, and when we go on the production, we need to take care of few simple steps. First is IP filtering. As we discussed, by default, Solr instance is open. First thing we can do is to lock it down by IP. So only your Sitecore instance can see them, which is basically CM, CD, XNAC, etc. This is simple enough and can be done without much efforts. Firewall. Make sure the Solr instance is internal behind a firewall. Solr instance for Sitecore does not need to access by public visitors. so there is no need to be exposed outside your internal network. TLS, it is important to encrypt traffic to from Sitecore and between Solr node. Prevent sensitive data to be leaked out on the network. We recommend to add a real SSL certificate for your Solr instance. Basic authentication. Although basic authentication is not available in Sitecore out of the box, and it will require some changes in Sitecore, but it's an extra layer of security. Then come to the disk encryption. Few organizations are more concerned to their security, especially with their internal system. Disk encryption is an option for encrypting the indexes on the disk itself, but it costs the performance since there are extra processes to encrypt and decryption. There are some security plugins are available in Solr, but it do not recommend to use that level of security since Solr instance with Sitecore is always internal and behind the firewall.
Memory management. Configuring your JVM can be a complex topic. Luckily, most modern JVMs are quite good at making the best use of available resources with the default settings. There are two primary command line options that set memory limit for the JVM. These are XMS, which sets the initial size of the JVM memory heap, and XMX, which sets the maximum size to which the heap is allowed to grow. If a Solr application requires more heap space than you specify with the XMS option, the heap will grow automatically. It's quite reasonable to not specify an initial size and let the heap grow as needed. The only downside is somewhat slower startup, since the application will take longer to initialize. The maximum heap size set with XMX is more critical. If the memory heap grows to this size, object creation may begin to fail and throw out of memory exception. Setting this limit too low can also cause errors in the application, but setting it too high can also be detrimental as well.
Sharding is a key element for the performance. So create multiple shards for large collections. Shard is a logical partition of the collection containing a subset of document from the collection. For document writing, use router.name parameter while creating collection. You can also split shard into two pieces by using collection APIs.
Performance testing for search functionality. Once we set up everything, it is good to do a performance testing for checking speed, scalability, and stability. Speed to determine the Solr response, scalability to determine user load can handle by Solr, and stability to determine the application is stable in various load. There are a few tools which we can use for performance testing such as JMeter, SolrMeter. SolrMeter is still available to download but is currently not under the development, and there are lots of other tools available in the market for perform the performance testing for the search functionality. With that, we are done with our session. Thank you for attending the session. Feel free to reach out us on social media platform if you have any question.